All right, so we're going to look at 41. Where's 41? Oh, I did this with the other class, number 41. So let me explain something to you guys here. So I'll erase this just so we can go over this again. But it says, state the domain and range of each graph, and then is it a function? So to figure out if something is a function, you're going to want to do the vertical line test. So notice every time I draw a vertical line, the red line only touches it one time per line, right? So since it passes the vertical line test, then yes, it is a function. All right, so since it passes the vertical line test, it is a function. Now, the harder part, I guess, for some is domain and range. So domain and range is found by figuring out, well, first off, domain, how far left and how far right. Let me write that down for you guys, okay? How far left and right. And then for range, it's how far down and up. So let's do the range first, okay? That one usually is easier for people to understand. So how far down does this graph go? What's the lowest it reaches in terms of y values? Well, wouldn't it be like right there? That's as low as the graph goes, right? So what's the height of it in terms of y values? What's its height? So wouldn't this be a 0 as to how low it went in terms of y? So I'm going to put a bracket because it actually does include the y value of 0. How high does it go? Well, for the height, you're going to want to focus over here. So I'm kind of highlighting it. Isn't it going to just keep going up forever? Right? And I'm going to highlight the other end right here. But it keeps going up forever. So what you guys are going to write is positive infinity. And remember, whenever you write infinities, you don't put a bracket. You got to put a parenthesis. Okay? Now, the domain. How far to the left will this thing keep going? So notice it has an arrowhead, right? So it keeps going to the left as much as possible. Okay, it's never going to stop going left. So then you're going to write negative infinity as in terms of how far left it's going. Now, how far to the right is it going to go? Well, it's going to keep going forever. I mean, right here we just have the picture, but it's going to keep doing this forever and ever and ever and ever. It's never going to stop. Okay, so we put positive infinity. Okay, so I got to put that again here. Yes. But domain and range, it's kind of a weird thing. But domain, just think of how far to the left is it going? How far to the right is it going? Okay, if it has arrowheads, usually it's going to have a domain that's infinite, like negative infinity to positive infinity. But the range can vary depending on how high and how low it goes. So that's 41. Anybody else? No? All right, so like I said, tomorrow we have a 35-minute period. Not a lot of time to ask questions, so if you can, by tonight, see if you can finish this thing up. That way, if you have questions, you can ask tomorrow. After tomorrow, whatever's not done, you guys are responsible for doing on your own. Remember, you're getting extra credit for completeness. So if you turn it in and the whole back page is missing with stuff, then I can't give you the extra credit. Okay, just try it. All right. So let's go back to where we were at. I think we were at 32. So true or false? 5, 3 is a solution to this function. Oh, we did those? Yeah. Oh, okay. So what did we get? This was a true, right? Yeah. And the other one was a false. Okay. So then with you guys, we got to 34. Okay. Maybe I need to learn to spell there. Okay. So write an equation of the absolute value function that opens up, translates 8 to the right, and translates 5 down from the parent function. So let me give you guys the main equation that you need. Y equals a times x minus h plus k. Remember, we know the vertex form for parabolas. We also know the vertex form for absolute values. Now, first off, let's do the first part that it tells us. Write an equation, the absolute value function that opens up. Now, notice they don't tell us that it scales or that it has a multiple of, nothing like that. So my a value is going to be a 1. Okay? My a value is a 1. It says it opens up, so it's a positive 1. So I'm going to write y equals 1. Then I put parenthesis, x minus, and then let's figure out the rest of this, okay? So it says it translates 8 to the right. 8 to the right. So if it goes to the right, that means that the number inside of the parentheses should be negative, okay? It should stay negative, and you're going to put an 8 right there. If it goes to the right, it should say minus 8. And that should be in your notes, guys. If it goes left, it should say plus a number. If it goes right, it should say minus a number. And then they say that it translates 5 down. So instead of plus k, I got to put minus k. So minus 5. So there's my equation. Now, in the multiple choice, they may not include the 1, so you might see it just might look like this. But we did a lot of this stuff in the notes and stuff, so just go back and look at your absolute values section. And that was all there. How to figure out the translations if they just give it to you verbally. Okay? So translating 5 down, 8 to the right. So let's look at 35, true or false. The absolute value function of this translates 4 to the right and 6 up. Well, we just talked about this. If it's minus 4, it goes to the right. Okay, so it says translates 4 to the right. That's good. And then if it's a plus 6, that means it's going up 6. That says 6 up. So this has to be true. All right. 36. Find the value of k of t equal to 2t plus 1 if they're trying to get you to do k of 2. In other words, if t equals to 2. That's what this means, okay? If t equals 2. That's what that little piece means. Okay? So do me a favor. Plug that in and work it out while I pass this out. Lewis. So if you plug in a 2, what do you get as an answer? 5, right? So it's just 2 times 2 plus 1, which is 4 plus 1, which is 5. So there's your answer for number 36. If it says, go ahead. Yeah, go ahead. All right, graph each equation. So 37, 38. Let me highlight something here. Negative. That means that every absolute value looks like a letter V. It might be upside down, but it's going to kind of look like the letter V. In number 37, since it's negative, then it's a V that opens up down. So it's an upside down V. Now, this number here, the plus 1 and the minus 1, give me my vertex, okay? So that plus 1 really means negative 1, right? It's always the opposite. And then the minus 1 on the outside is always what you see. So here is my vertex. Okay, and then once you get that, just know that it opens down. So you're just going to draw it like this and like this. And you're done. There's no calculation of points or anything like that. You just basically figure out which way it goes. Now, you'll notice for number 38, I'm going to highlight something here real quick. There is no negative there. So that means this looks like a normal V, right? It's opening up. Now, minus 2 and minus 1 in terms of a vertex means 2 comma negative 1. Remember, it's always opposite of what you see inside of that absolute value. So 2, -1 is here. And then you're just going to draw the V shape. And there you go. So those should be pretty quick. I mean, if all else fails, if you don't know the technique that I'm going over right now that we went over in class, what's your last resort? Like, what can you do to graph it? If you can't remember how else to do it, what's your last option? Anybody know what your safety net is? No? Well, then it's good for me to tell you now. If all else fails, guys, pick points. Okay? Pick a lot of points. Calculate them. That way you can get your answer. Okay? That's your last resort. Like, this is always your fallback. If you can't remember the technique, then you can always fall back to picking points. Okay? Remember, that's the first way you ever learn how to graph a function, is by picking points. And it always works. It's just, it might take a lot of points for you to actually get it right. But you might have to do like 5 of them. So maybe not the best way to do it, but still a way that you can count on. All right, 39. Sketch the graph of each linear inequality. All right. So for these, they say linear. Okay, notice the root word of linear. The root word is line. Okay, that means these are lines. Now, y greater than or equal to -2x plus 5 resembles this. Okay, that means that I'm going to begin at a +5. So here it is, +5. And then I'm going to move based on my slope. My slope is -2/1. So 2 down 1 over, that's right here. Now I'm supposed to connect these dots, but notice how I have an inequality. Let me highlight that for us. Inequality means that the line can be solid or dashed. Now, since it says greater than or equal to, that means that this line will be solid. If it said just greater than, then it would have to be a dashed line. Okay? And then I have to shade this stuff in. And the way I know whether to shade it above or below is based on if it says greater than, meaning up, or less than, meaning down. So mine says greater than or equal to. So I'm just going to shade everything above it. So this is kind of what yours should look like, okay? I did have a student the other day ask me, like, how do you know you shade? Well, if it's an inequality, that means to shade, okay? So let me put that right here. An inequality tells you have to shade above or below. So look at number 40. Am I going to be shading above or below? Since it says less than or equal to. Below, right? Less than means down, okay? Is my line going to be solid or dashed based on this little piece right here? It's going to be solid because it says less than or equal to, right? So notice I only have one variable. There's no x and y, there's just a y, so it makes it one-dimensional. That means that this is either a flat line or a vertical line. So what I'm going to do is I'm going to go to 3 on the y-axis, okay? And you guys should know that anytime it says like y equals 3, y equals 7, those are horizontal lines. Solid, because of the inequality saying or equal to. And it says less than or equal to. So you just shade under. Doesn't have to be perfect. And remember, guys, you guys will know whether or not you have to shade, because since this is a multiple choice test, the multiple choices will have graphs with shading in them. So you'll know, like, oh yeah, I got to shade this, and the line should be dashed or solid. It'll show up for you. Any questions on those? All right, so let's keep moving on. We already did 41. True or false? So given y equals to negative 2 times x minus 3 squared minus 13, the axis of symmetry is negative 3. Now, I told you guys that this number in this form is your axis of symmetry, but is the number that I'm pointing at a negative 3 or a positive 3? It's positive. It's always opposite of what you see. So this is false. The answer is x equals 3, not negative 3, positive 3. Remember, the numbers inside of the parentheses or the numbers inside of the absolute values are always opposite of what you see. So let's look at number 43. Given that the parabola opens down, what do you guys think? This parabola opens down. That's true, okay? See negative 12 in the front? Your a value, I'm going to write since a equals negative 12, then this is true. If it would have been a positive 12, that means that it opens up. Okay, but negative 12 means that this parabola opens down. All right, let's look at 44. Given that equation, the vertex is negative 3, negative 3. What do you guys think? Does it look like negative 3, negative 3? Yeah, it is, right? I know it says plus 3 on the inside, but it's always the opposite. So this is true. All right. Given 2x squared minus 4x plus 5, the axis of symmetry is x equal to 2. Well, I can't just look at that one because this is in standard form. So axis of symmetry is given by this equation. So negative b, that's well, let me actually write it down. It's negative of a negative 4 over 2 times 2. So that'd be 4 over 4, which is 1. So this would be false. If they would have said the axis of symmetry is equal to 1, then yes, that would be true. All right, the next one, given y equal to 2x squared minus 4x minus 3, the y-intercept of the graph is 0, negative 3. Is that true or false? That's true. Since this is in standard form, the negative 3 is your y-intercept. And y-intercepts are written as 0, and then your number. So this is true. All right. Given y equal to x plus 4 quantity squared minus 2, the parabola translates 4 to the left and 2 times down. Well, 2 down makes sense. Okay, minus 2, 2 down, that's fine. That's good. 4 to the left, and it says plus 4. Well, that makes sense too, because if it says positive, you go left. If it says negative, you go right. So this is true. So that is a true statement. 48, given that the parabola has a minimum vertex. Now, in order for a parabola to have a minimum vertex, it has to open down. That way you have up. Has to open up because then you have a minimum. Which direction does this parabola open? Down. So if it opens down, that means you have a max. So the parabola has a max vertex. That sounds good, right? So that would be true. If it opens down, it must have a maximum vertex. If it opens up, it must have a minimum. This one opens down, so it must have a maximum vertex. Number 49, the first step of factoring is to factor out the greatest common factor if possible. True or, yeah, that is true. I was going to say true or false, but yeah, that is true. The GCF is always the first step. Always. Okay, and then from there you can check to see if you got to do the X method or difference of two squares and things like that. So GCF always true. All right. 50 and 51, these are supposed to be gimmies, okay? Hopefully you guys remember this, but if you don't, good thing we're doing them now. Name the zeros. In other words, the zeros of a function, when you look at the graph, is where it touches the x-axis. So that happens right here and right there. So I have two answers. X equals 3 and x equals 5. Those are my zeros. Okay, 3 and 5. What about 51? Does that ever cross the x-axis? No, so then you write no solution. So whenever they want you to find the zeros or the solutions or the roots, remember they could use this word or roots or solutions. Okay, they could use any one of those. So any one of those words means look at the actual values where it crosses the x-axis. Okay. All right, 52 we did. All right, factoring. So here we go. So for number 53, we're going to factor these things. Now notice they have an n in common. They have actually two n's in common. And they actually share 2's as well. Okay, the number 2. So we might just do this one and that might be it. So, because we're going to run out of time. So let's just do this one real quick. So I'm going to factor out a negative 2n squared. Because they all have a negative 2n squared in common. So if I factor out a negative 2 from the first term, I get a 3. And if I take away 2 n's from n to the fourth, I get n squared. Now, if I divide the positive 4 by negative 2, I get minus 2. And if I divide n cubed by n squared, I'll get n to the first. And then if I divide 16 by negative 2, I get a negative 8. And if I divide n squared by n squared, that goes away. So all I have to do now is factor 3n squared minus 2n minus 8. So let's do that really quick. So 3 times negative 8 is negative 24. And the negative 2 goes here. I'm doing this, okay, guys? This is what I'm doing. Two numbers that multiply to negative 24 but add up to negative 2 would be a negative 6 and a positive 4. But notice I got to divide by 3. Okay, that 3 makes me divide. So let me divide by 3. This gives me a negative 2. And if I divide that by 3, well, I can't do anything with it. So there you go. So those are my two factors. So let me write them out here. Negative 2n squared times n minus 2 times n plus 4 thirds. But remember, you shouldn't leave fractions in your factored form. So I'm going to get that 4 thirds. I'm going to get the 3 and move it right there. Okay, I should not have done that piece with the marker. Give me a second. So I'm going to move that thing in front. Okay, and then I'm done. So negative 2n squared times n minus 2 times 3n plus 4. And that's my factored form. We can do more of these things tomorrow, but for now we'll stop. All right, so for number 58, what we're going to, first off, notice it says sketch each parabola, right? So we know it's a parabola that we're going to be working with. But number 58, notice the fact that it's negative in the front, which means that the parabola has to open down. Okay? So the parabola opens down. Now, another thing you should notice is this type of equation is written in standard form, ax squared plus bx plus c. And this plus c portion, This is called your y-intercept. That means that at -5, so I'm going to kind of highlight it there. At -5, I'm going to put a point on the y-axis. So here it is. Okay, so I already know that point exists right there. Now, the way you graph parabolas is the very first thing you want to try to do is find your axis of symmetry. So to find your axis of symmetry, you're going to have to use the formula of x equals -b over 2a. All right, now my b value is a 4 and my a value is a -2. So let me write that down. -4 over 2 times -2. So that's equal to 1. Okay, that's my axis of symmetry. I'll put it right here, AOS, axis of symmetry. So I'm going to draw it, okay? Here's my axis of symmetry. That means that it cuts the graph vertically in half. So you see that green dot that I have there? I'm going to copy it on the other side as well, because it's symmetric. Okay? Now, once I get my axis of symmetry, I gotta find my vertex. Now, number 57 is a lot easier because the vertex is given right here. It's a -4, -2. That's my vertex for that one. So that's a lot easier to do. But when it's in standard form, you actually have to calculate your vertex. So let's get the axis of symmetry that I just found, and I'm going to plug it in to that equation right there. So it's y equal to -2 times 1 squared plus 4 times 1 minus 5. So if I work this out, this is -2 plus 4 minus 5, which is -3. So my vertex is 1, -3. So I'm going to put that dot, 1, -3 right here. And all I have to do now is connect the dots in a U shape. And that's my sketch of the parabola. Now, if I can really show you 57 right now, let me just give you a couple seconds to finish writing that out. But let me just show you how 57 is and how easy it is to do that graph if it's in that form, okay? Because 58 is in standard form, 57 is in vertex form. So let me show you here. Number 57, according to this equation, my vertex is -4, -2. Remember, it's always the opposite of what's inside the parenthesis, and then the number on the outside. So -4, -2. So I can put my vertex right there. Now, I know that this opens up because right here in the front, there's no number, so it's positive, right? If it was negative, you'd see a negative symbol. So there is no number. So I know it's going up. So all you have to do is go like this. And you're done. You sketched it. Okay, and some people say, well, how do you know where you should go? Sometimes for this one, you just go one up and one over. That's where you put your next one, okay? In both directions. So then you have that. So you'll have those points right there. But you don't have to put those green dots on the left side. It's okay just to leave it with the one red dot. Okay, so I mean, do it however you'd like, but vertex form definitely much easier than standard form. Is there another problem? I think I saw Ezekiel, you had one, and then I'll check over there. 54. 54, and then yours was?
No, I was going to ask about the green points. How did you get the first one?
The one on the right side, 58? So it's right here.
No, 57.
Oh, the green points, you basically just go from your vertex. If you know it opens up, go one up, one over. Yeah. So, all right. And 54. So let's go to 54. Factor each completely. Number 54. 7, let me see. 8, 9, 7, 8, 9, 10, 11, 12. Can they all be divided by 6? Let me check. I'm going to need my calculator for this, so give me a second here. 147 divided by 6 does not work, but they all can be divided by 3. So let's see. I'm going to take a 3 out. This will be 5r squared minus 49 plus 108 divided by 3 is 36.
It's 49R.
Oh, 40. Oh, yes, thank you. 49r, thank you. All right, and that's as best as I can do it. So what I'm going to have to do at this point is try to find a way to factor this piece right here. And let's see if we can do that. Okay? So I'm going to do an X method up here, okay? So I have 5 times 36. That's 180. And then a negative 49 right there. So two numbers that multiply to 180. Let me see. This is going to take me a little while to think of. 180 divided by... no, it doesn't work. What about 180 divided by 6? Nope. 3. Nope. Is that even possible? Let me check if this may not be possible. Is that why you're asking me if you can do it? Because I'm checking the factors. So check it out, guys. 180. You can do 1 times 180, 2 times 90, 3 times 60, which does not give you 49. Oh wait, 4 and 45 does. 4 times 45. So how would I do it? A negative 4 and a negative 45. So that'll work. I didn't think about 4s. Now, since there's a 5 right here, that means I got to divide by 5. So let me put the 5 right here to divide it by that. Negative 4/5 is going to stay the same, but this will become a negative 9. So here's my factor before I fix it. So it's 3 times r minus 4/5 times r minus 9. But you can't have fractions, so we got to get that 5 and put it in front of the r value. So it's going to be 3 times 5r minus 4 times r minus 9. And that's the answer to this one right here. So you guys are copying that down. Anybody else have another question that you'd like me to do? Number 77. So let me just wait till people copy that. Remember, I'd rather do the questions you have than just going in order, because this to me means that I'm helping people who've tried it and they've struggled, so maybe other people will struggle too. So it's good to get those out of the way. So number 77. It's all the way down here. By the way, you guys may have noticed a bunch of writing right here. Number 64. It'll be in the notes, okay? But someone asked me if I could do number 64, and 64 is a tough one. But I told them, remember, this is a multiple choice test. On a question like this, doing the work takes a long time. But since you have multiple choice, you could always just get the answers they give you and plug them in and see if they work. And if they do work for both equations, that means that's your solution, right? Working backwards. But if you can do it easily, then go ahead and do it. But that one's done for you guys. It'll be in the notes, okay? So don't worry about having to copy that down right now. It'll be there. I don't know if there's any other ones that they asked me to do over here. All right, so number 77. Use the quadratic equation to solve each application problem. So we might have to use that big equation here. This is the quadratic equation. X equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So they said the height h in feet above the ground is given by that equation right there, where t is time in seconds. How high did the object start off of the ground? Okay, so how high did the object start off of the ground? And they say find the maximum height of the object. Hint, find the vertex. Okay, so if you're starting, I'm going to give you a real quick hint on this thing, okay? Because I feel bad not giving you this information, because honestly, if anybody teaches you this formula, here's the first thing they tell you. So let me give you this information here. This is the original formula where this comes from, okay? So just bear with me before you start freaking out, okay? Just listen to me real quick. So, how did they get the negative 16? Well, gravity, acceleration, A, is negative 32 feet per second. Now, half of negative 32 is negative 16. So that's how they got the negative 16, okay? This part is the negative 16 part, okay? So let me write that down right here. Negative 16t squared plus. How many of you guys have taken physics here? Anybody taking physics? What does V naught mean? V initial. What does that mean? The velocity you start with, right? So how fast did this object go to start with? What is the number according to the equation? 64, right? 64t. What is S naught? That's 190, but what does it mean? S sub 0. No, that actually means where you started. S sub 0 means your starting height. So let's read the question. How high did the object start off of the ground? What should I say? 190. Okay, so starts at 190. Did they say feet or anything? Yes, feet. Okay, so how high did the object start? At 190 feet. Okay, so that's the first part. It says now find the maximum height of the object. In other words, they want the vertex. They want the vertex of this problem. So this was like answer to problem A, I guess. The next one, we got to find the vertex. So since this equation is in standard form, then I first have to find the axis of symmetry. And then I can find the vertex. So I'm going to use t equal to negative b over 2a. In other words, it's normally x equals negative b over 2a, but we're using the letter t because that's the variable that we're given. So I'm going to plug in my b value, which is 64, and 2 times negative 16. That's my a value. So that's negative 64 over negative 32. That's 2. So all I have to do now to find my vertex, my high point, is to get that value of 2 and plug it back into that equation to find my height. So negative 16, 2 squared, plus 64 times 2, plus 190. So what is that? Negative 16 times 4, plus 128, plus 190. H is, what is that? Negative 64 plus 128 plus 190. I'm just doing this by hand. If you had a calculator, I'm hoping you'd be using it by now. So what do we get? 4, 5, 2. So 254 feet. That's the maximum height. I just found my vertex, but I'm applying it differently. Okay, but I basically did was just found the vertex. So my vertex would be the point 2, 254. But they just want the height, so they want the y value. So there it is. Now notice you're not cheating by doing what I taught you. The position formula is a very common formula. Those of you guys with some physics background, you'll notice the formula and say like, oh, I remember seeing this before, right? So you might be able to say, oh, okay, that equation reminds me of the position function, and so the number at the very end, my 190, that's where I started. Okay, so hopefully you guys remember that. If you don't remember that, this is how you find it. Okay, so let me at least give you a hint in case you've never taken physics and you're like, Mr. V, I'd have no idea how to find out that it's 190. This is how you do it. What time is it when you first start? Like, you know how you can say time is 1 second, 2 seconds, 3 seconds, etc. What's the value of time when you first start an experiment? 0. So all you have to do is plug in a 0 into your equation. But notice what happens. That'll cancel, so the only thing left is your original height. So that's how you can do it. If you didn't know anything about physics, then you apply it like that. Plug in 0. Okay, so I'll just put it right here. Plug in 0. So you can find that if you want to. Okay, or you can use the physics formulas. I know I did a little bit of extra work there, just teaching you some extra stuff, but maybe it's helpful, maybe it's not. If you don't like it, then forget about it. But at least remember plugging in the 0, because you plug in the 0 to give yourself your initial position. Okay, where you started. Any other questions? I'll give it a couple seconds. Meanwhile, I'll be scrolling back to the original, or the place where we left off. All right.